Alright class, I'm back and saw the video. So if you take a look here, we're going to talk about, continue our discussion of the Pythagorean Theorem. And if you remember that from middle school, that the Pythagorean Theorem says if you have a right triangle, and that's our hypothesis, then the conclusion is the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in other words, this is only true if you have a right triangle. If you don't have a right triangle, then that is no longer, we can't say that a squared plus b squared is equal to c squared. Okay? And so that's where it becomes important to know. So today we're going to take a look at the converse of this statement. And if you remember, the converse of a conditional statement is when you're switching the hypotenuse with the conclusion. So even though in the original Pythagorean theorem the hypothesis was if you have a right triangle, and the conclusion is the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs, we're going to switch it up for the converse of the Pythagorean theorem. So what the converse says is if you have the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the two other sides, then you can say for the conclusion that the triangle is a what type of triangle? A right triangle. So in order for us to say that we have a right triangle, if we don't know the angle measurements, if we can show that the square of the length of the longest side is equal to the sum of the squares of the other two sides, then we can say we have a right triangle. So that is what the converse of the Pythagorean theorem says. So in other words, if you have c squared is equal to a squared plus b squared, then you can say the triangle is a right triangle. So how does that help us? Well, it tells us that we have a way other than looking at the angles to determine if a triangle is a right triangle. Well, if we have a way of determining if it's a right triangle by just using the side lengths, is there a way that we can determine if it's an acute triangle or an obtuse triangle by just using the side lengths? And actually there is. So let's take a look at Geometry Sketchpad to show our. So here we have three triangles, and from a glance they look to all be right triangles, but we can't say for sure they're a right triangle because we don't know any of the angle measurements. So we can't say for sure if it's a right triangle because we don't know about the angle measurements. But what if we knew the side lengths? Just by looking at these side lengths, do we have enough information to determine what kind of triangle it is? Well, by using the results of the converse of the Pythagorean theorem, we can determine if it is a right triangle, because if it's a right triangle, then we can say that if the longest side is c, is c squared equal to a squared plus b squared? If we can show that c squared is equal to a squared plus b squared, then we can say that it is a right triangle. So let's take a look. Is c, which is AC, is that equal to a squared plus b squared? So what do we see? We see one is 54.57 and one is 54.92. So what does this tell you? Is this a right triangle? No, it's not a right triangle. So we know for a fact that this is not a right triangle. So we can say that because c squared is not equal to a squared plus b squared, then we can say that this is not a right triangle. Let's see about this triangle. Is c squared going to be equal to a squared plus b squared? Well, let's see. C is df, and let's see what happens when I square df. I get 62.25. And a is fe, and in B is ED. Let's see what happens when I square those two and add them up together. Do I get that c squared is equal to a squared plus b squared? And as you can see, no, it's not. So we can say for a fact that this is not a right triangle, even though we still don't know anything about the angles. Now let's take a look at this triangle. If this is my C as the largest side, 6.79, and this is my A and my B, is C squared going to be equal to A squared plus B squared? Well, C is GH, so here is GH squared, and A is HG, and B is JG. Let's see what happens when we square that. And look, what do you know? C squared does equal A squared plus B squared. So we can say that we do have a right triangle. So you have a way of determining if a triangle is a right triangle by comparing the results of summing the squares of the two smaller sides and comparing it with the square of the larger side. Now let's take a look at the angles. And take a look at the angle measurements. As we can see, this triangle has no right angle, though the largest angle is kind of close to it. This triangle has a angle that's close to 90, but it's actually higher than 9 degrees. And this angle has a triangle that's exactly 90 degrees. So our theorem was right that if C squared does equal to A squared plus B squared, you have a right triangle. But if C squared does not equal A squared plus B squared, then you do not have a right triangle. But can we also determine which one is an obtuse or an acute triangle? Well, let's take a look here. Because all the angles here are less than 90 degrees, we can say that this is an acute triangle. And because all the angles here, and because one of the angles is more than 90 degrees, we can say that this is an obtuse triangle. But again, we had to use the angle measurements to determine if it really is the case. Let's see if there's a way we can use the side lengths to be able to determine that same information. So as we know here that for these two triangles, they are not right triangles. But let's see, how does C squared compare to A squared plus B squared? C squared in this triangle is 54.57, and A squared plus B squared is 54.92. So in this case, C squared is smaller than A squared plus B squared. C squared is smaller than A squared plus B squared. And in this case, C squared is 62.25 and A squared plus B squared is 61.38. So we can say that C squared is bigger than A squared plus B squared. So does that mean we have a way of determining if it's not a triangle, what type of triangle it is? Will an acute triangle always have C squared being less than A squared plus B squared? Let's see. So, well, for an acute triangle, will we always have that C squared is less than A squared plus B squared? Well, let's change this triangle and still make sure it's acute, but let's see how C squared compares to A squared plus B squared. So let's show the angle measurements. And I want you to take a look here to see, do we always have this situation that C squared is smaller than A squared plus B squared for an acute triangle? So as I change the angle measurements so that I have an acute triangle, is C squared going to be less than A squared plus B squared? What do you think? It looks like it is. Then as long as we have an acute triangle, no angle more than no angle equal to 9 degrees or larger, we're always going to have that A squared is less than or equal to B squared. So for a acute triangle, C squared is always going to be less than A squared plus B squared. Now let's take a look at this obtuse triangle. Is this obtuse triangle going to stay obtuse as I change A squared, A and B, to make sure that one of the angles stays obtuse? Let's see. So here's an obtuse triangle. Let's take a look. Is C squared bigger than A squared plus B squared? Yes, it is. So in fact, no matter how obtuse the triangle is, C squared is still bigger than a squared plus b squared.